Hi everyone, this is Dr. Nuck, and we're going to go over section 8.2, continuation of the inverse trig functions. So what I did was I already wrote down what we have learned in the previous section involving sine, sine inverse, cosine, cosine inverse, and tangent inverse. So in this section, what we're going to be doing is we're going to be learning about secant inverse, cosecant inverse, and then cotangent inverse. So let's just look at the second box with the star on it. Secant inverse of secant of x equals to x if x is between 0 and pi. Secant of secant inverse of x equals to x if x is greater or equal to 1 or x is less than or equal to negative 1. Cosecant inverse of cosecant of x equals to x if x is between negative pi over 2 to pi over 2. And cosecant of cosecant inverse of x equals to x if x is greater or equal to 1 or x is less than or equal to negative 1. Okay, cotangent. Cotangent inverse of cotangent of x equals to x if x is strictly between 0 and a pi, but x cannot be 0 nor pi. Now, cotangent of cotangent inverse of x equals to x for all number of x. All number of x meaning all real numbers, I meant. Let's do some examples. Example 1, find the exact value. So let's first look at tangent of sine inverse of negative 1/2. All right, let's try to deal with this problem first. Okay, so step number 1, let sine inverse of negative 1/2 to be theta. So I'm going to say let theta equals sine inverse of negative 1/2. Now in this case, our theta must be between negative pi over 2 to pi over 2. This is from the previous section. So that implies that sine of theta is negative 1/2. Okay, so let's talk about where the sign is negative. Let me just write. Sine is negative. Okay, so let me just draw the positive quadrant. Okay, so sine is negative in which quadrant? Quadrant 3 or in quadrant 4. But remember, theta has to be between negative pi over 2 to pi over 2. So here's pi over 2, negative pi over 2, so it must be in here. So let me just circle the possible spot where the sign can be negative. So that means that our angle theta must lie in quadrant 4. So I'm going to cross this one out. Okay, so keep that in mind. Now, from here, a couple ways that you can do, but I'm going to look at this as a triangle. So sine of theta is opposite over the hypotenuse. So let's forget about the negative for now. And this is telling you the opposite side of the angle theta has length 1. Hypotenuse has length 2. Now remember this triangle, right? So the bottom length is going to be square root of 3. Now our theta in this case is what? Theta is 30 degrees, which is going to be pi over 6. So from the x-axis, you're going to have to go down pi over 6 units towards the fourth quadrant. Okay, so let me just draw that situation in the positive quadrant picture that I just drew. So what you need to do is go down pi over 6 units. So let me just go over here. I hope you can see this. I'm sorry if you cannot. So theta is negative pi over 6. And length here are 1. And this side is square root of 3. And hypotenuse is 2. So if you want to plot this point right here, my gosh, it's looking really ugly. All right, this point right here, our x value or the a is square root of 3. and then b is, or the y value is, -1. Now, since negative pi over 6 is between negative pi over 2 to pi over 2, we're good to go. Let me write that out. Okay, so in this case, sine of theta equals -1/2. That implies that theta must be negative pi over 6. Alright, but our theta, I wrote it out in green over there, our theta was nothing but sine inverse of -1/2. So let me insert that. Okay, keep that in mind. That is my refrigerator. Okay, so therefore, tangent of sine inverse of -1/2. This is our tangent of theta, which is tangent of negative pi over 6. Now, I don't like to deal with the negative angle. Now remember, tangent is an odd function, so using the property of odd function, you could pull the negative sign outside of it and just have tangent of pi over 6. Now to compute the tangent of pi over 6, you can memorize the chart if you like, or just look at the triangle that we drew earlier, which what I mean is this triangle right here. Now tangent is opposite over adjacent, so in this case the opposite side of the angle has length 1, adjacent side is square root of 3. Always rationalize, so I'm going to multiply here by square root of 3 over square root of 3. So therefore it looks like our answer is going to be negative square root of 3 over 3. And let me just box that for the final answer. Let's do another similar example. Let's call this example 2. Let's find what the secant of cosine inverse of 1/2 is going to be. Okay, we're going to do the same thing as what we did earlier. So let's call cosine inverse of 1/2 equals theta. And so that implies that cosine of theta equals 1/2, and theta is between 0 and a pi. Now notice that in this case, our cosine of theta is positive. So now let's draw the positive quadrant and figure it out where the angle is going to be. Okay, so cosine is positive in quadrant 1 and quadrant 4. But the thing is, theta better be between 0 and a pi. Oh, sorry, let me just circle the possible ones. Here we go. But theta must be between 0 to pi, which is from here to here. So that means that theta must lie in quadrant number 1. So let me cross the quadrant 4 out, and I'm just gonna box that. Okay, now cosine is adjacent over hype, so let me just squeeze this in here. Adjacent over the hypotenuse. So if I have to draw that triangle, adjacent side of my angle theta has length 1 and hypotenuse is length 2. So does it look familiar now? So our theta is 60 degrees, which will be pi over 3. Now, is pi over 3, is it inside of 0 to pi? Yes, it is. So, since 0 to pi, we are good to go. Oh, before that, let me draw the triangle in the first quadrant. So what's going to happen is you're going to revolve Here we get theta equals to pi over 3. And if you want to draw the triangle, that's fine. So our length is going to be 1, 2, and then square root of 3. All right, so let's keep going. Now, since pi over 3 is in between 0 and a pi, cosine of theta equals 1/2. That implies that theta must be pi over 3. Okay, so therefore, secant of cosine inverse of 1/2. Now, cosine inverse of 1/2 is our theta. So here, we're going to get secant of pi over 3. Okay, now this is same thing as 1 over the cosine of pi over 3. Okay, now if you look at the triangle that we drew above, cosine is what? Adjacent over the hypotenuse. So the cosine adjacent side is 1, hypotenuse is 2. So it looks like our answer is going to be 2. Okay, let's do another example. Let's find what the cosine of sine inverse of negative square root of 3 over 2 is going to be. Now feel free to pause right here and try to figure it out what the answer is. But anyways, let me just keep going then. So first, I'm going to say let theta equals sine inverse of negative square root of 3 over 2. So that implies that sine of theta is negative square root of 3 over 2. Now I forgot to write the theta is between negative pi over 2 to pi over 2. Now sine is negative. In which quadrant? So let me just draw the positive quadrant again. Okay, so let's figure it out. Sine of theta is negative in quadrant 3 and a 4. All right, now, but the theta must be between negative pi over 2 to pi over 2. So here's our pi over 2, negative pi over 2. So it has to lie in here. Okay, so with that said, which one can we eliminate? The third quadrant. So our angle theta is going to lie in quadrant number 4. Okay, so let's do the same deal that what we've been doing. Now sine is what? The opposite over the hypotenuse. So the opposite side of the triangle has length square root of 3 and hypotenuse is 2. So the bottom length has to be 1. So it looks like our angle that we're going to get will be what? 60 degrees. So it looks like it's going to be pi over 3. But the thing is, it's going to lie in quadrant number 4. So from the initial side, you're going to have to go down pi over 3 units. Meaning, let me just change the colors around. So in this case, our theta is negative pi over 3. Now, if you want to draw the triangle, that's fine as well. So in this case, our length is going to be square root of 3 here too, and a 1 completely drawn off the scale. I apologize. All right. So, but in any case, since now let's check to make sure the negative pi over 3 is between negative pi over 2 to pi over 2. And yes, it is. So I'm going to write since theta equals negative pi over 3 is inside of negative pi over 2 to pi over 2, we're good to go. So, therefore, sine of theta equals negative square root of 3 over 2 means that theta is negative pi over 3. Okay, so keep that in mind. All right, so what do we got so far? So therefore, cosine of sine inverse of negative square root of 3 over 2. So this is nothing but our cosine of theta, which is cosine of negative pi over 3. Now I'm going to use the even and odd properties for the cosine. Now remember, cosine is an even function, so the cosine of negative pi over 3 is exactly the same thing as cosine of pi over 3. In case you forget, let me just make a note, because cosine theta is even. Y equals cosine is even. Alright, so now let's go with the cosine of pi over 3. So look at the triangle that we drew earlier. Cosine is adjacent over hypotenuse. So in this case, adjacent side of that triangle is 1. Hypotenuse is 2. So it looks like our answer is going to be 1/2. I hope you are getting hang of it. Well, don't worry, we're going to do another one, and again I'm going to write this out nicely on the notes which I will be posting on my lab math. Let's do another example. Okay, so let's take a look at secant of tangent inverse of 1/2. Okay, so we're going to start off with the same exact way. So we're going to let our theta be tangent inverse of 1/2. Now our theta is between negative pi over 2 to pi over 2, but it cannot be negative pi over 2 to pi over 2 because remember there is a vertical asymptotes there. So this implies that tan of theta equals 1/2. Alright, now tangent is opposite over adjacent. Keep that in mind. Oh, sorry, I skipped this step right here. Now tan of theta is positive in, let's determine which quadrant that is. Okay, so tangent is positive in either quadrant 1 or in quadrant 3. Quadrant 1 or in quadrant 3. But the thing is, theta better be between negative pi over 2 to pi over 2. So it has to lie in here somewhere. So which one's out? Quadrant 3's out. Cross that out. Bye-bye. And we're just going to keep quadrant 1. Okay, so now let's go back to tan of theta equals to 1/2, which is opposite over the adjacent. So the opposite side of that angle theta has length 1. So let me just squeeze it in here. And the adjacent side has length 2. Oh no. Is this something that we know of? Is it 30, 60, 90 triangle? Or is it 45 triangle? It's neither. So let me just label this as theta. Now let's determine the hypotenuse. Now, hypotenuse can be found as, I'm totally running out of room here, sorry. Okay, so the hypotenuse, let's call this h. I'm going to bring it over here. So our h is the square root of 1 squared plus 2 squared. So this is what? Square root of 5. So hypotenuse is square root of 5. Let me write that in black and let me erase that h. Oh, let's just keep the h. So h is square root of 5. I hope you can see that. So again, notice that this triangle, or I should say our theta, is not something that we're familiar with, which is what? Theta equals to pi over 6, pi over 4, pi over 3. So do not panic. There is a way to do this. It's a lot easier than you think. So let me draw that triangle in quadrant 1. So this was what, 1, 2, square root of 3. And this is our angle theta, which we don't know about. Okay, now this point right here can be represented as what, 2, 1? So keep that in mind. All right, so now let's take a look at this. So what we're doing is what? We're trying to find the secant of theta. Because look, we're calling this guy to be our theta. So pretend that this theta, not pretend, this theta is exactly the same theta as we drew inside of this triangle. So look at it this way. So therefore, secant of tan inverse of 1/2. Well, tan inverse of 1/2, we're calling that a theta. So I'm just going to put it like that. So guess what? All you have to do is stare at that triangle. Why did I write square root of 3 up in there? It's square root of 5. Sorry about that. All right. So all you have to do is this. Look at that triangle. And all you have to do is compute that secant of theta of that triangle. So let's take a look at secant of theta. Secant is what? 1 over cosine of theta. Now look at this triangle here. Okay, now cosine is what? Adjacent over the hypotenuse of that triangle. So here you're going to have 1 over adjacent side of the angle theta is 2. And adjacent over hypotenuse is square root of 5. So our answer is going to be square root of 5 over 2. As easy as that. And again, I wrote this out in great details on the notes, so you can stare at that a little bit, or feel free to go over this video for this problem. Okay, let's do another example. So this section seems like we're doing examples after examples. So cotangent of, let's go with sine inverse of negative square root of 2 over 3. So let's take a look at that. Now, feel free to pause this video right now and try to do this problem on your own to see if you can do it. And I'm just going to pretend that you paused it and try the problem. So let me just start off with this. We're going to do the same thing. So let theta be sine inverse of negative square root of 2 over 3. Remember, theta better be between negative pi over 2 to pi over 2. And this implies that sine of theta is negative square root of 2 over 3. Okay, so let's do the same thing. Oh, sine is opposite over the hypotenuse. And notice that sine of theta is negative. Okay, let's determine where the sign is negative. I'm pretty sure you figured that out already. So let me go with. Okay, so sign is negative in quadrant 3 and quadrant 4. Quadrant 3 and quadrant 4. But theta must be between negative pi over 2 to pi over 2. So it needs to lie in here somewhere. So which one's out? Quadrant 3 is out. So I'm just going to keep quadrant 4. Okay, now let's draw the triangle. So opposite side of angle theta has length square root of 2. Hypotenuse has length 3. Now again, this is not pi over 6, pi over 4, nor pi over 3 triangles. Alright, so let's get going here. So let's find the adjacent side of the angle theta. So I'm just going to call this guy B or something like that. Okay, so our B is square root of 3 squared, and that would be what? Minus square root of 2 squared. So looks like our B is square root of 9 minus 2. 9 minus 2 is 7. Okay, so the adjacent side is going to be square root of 7. Now let's draw that out in quadrant 4. I'm going to plot this point right here. So the length is going to be square root of 7, 3, and square root of 2. So this point right here is x is what? Square root of 7, and y is negative square root of 2. So you could think of this as your x, this is your y. Okay, so I think we are good to go. So therefore, oh sorry, let me just write down our angle theta. Theta is going, which way is that? Clockwise. So you know for sure that our angle theta is going to be negative. So keep that in mind. All right, so let's go. Oops. So cotangent of sine inverse of negative square root of 2 over 3. So this is cotangent of, we're calling this theta, which is same thing as cosine of theta over sine of theta. Okay, remember our answer must be negative because our angle theta is going clockwise. But if you don't believe that, let's use that x, y, and r. So remember, cosine was what? X over r. And then sine was y, was it y over r? So this is going to be x over y. So our x value, let's look over here. Our x value is what? Square root of 7. And the y value is negative square root of 2. So you see what I mean? It's going to be negative regardless. Now always rationalize the denominator. So here I'm going to multiply here by root 2 over root 2. So it's going to look like what? Square root of 14. Let me toss the minus on the top. And here you're going to have 2. So our answer is negative square root of 14 over 2. How are you guys doing up to here? Hopefully good. You know what? Let's keep doing more examples. So if you feel that you've had it enough, just start doing your homework. But I'm just going to go through maybe a couple more examples while we're at it. So let's call this one example 6. Okay, so let's go with something different. Cosecant of tan inverse of negative 2. Okay, so again, please pause the video and try this problem on your own to see if you can do it. Why am I pausing? Okay, so I'm just gonna keep going here pretending that you paused it. So let's do the same thing. So I'm gonna say let theta be tangent inverse of negative 2, and theta must be between negative pi over 2 to pi over 2, but it cannot be negative pi over 2 to pi over 2. Okay, so this implies that tan of theta is negative 2. Now, negative 2 is same thing as negative 2 over 1. Now, tangent was what? Opposite over adjacent. So keep that in mind. Now, let's determine where our angle theta is going to lie in. So, I'm going to go over here. Tan of theta is negative in. All right, so let's picture time. Okay, so tangent is negative in where? Quadrant 2 and quadrant 4. Okay, so let me just write that. Quadrant 2 or in quadrant 4. Okay, now let's check the domain for theta. So theta better be between negative pi over 2 to pi over 2. So it must lie in here. So this one is out. Quadrant 2, bye-bye. So we're just going to keep quadrant 4. Now let's draw that triangle. So opposite side has length, well, -2, but 2. So let me just write it like this. Adjacent side has length 1. Oh, why did I do that? That's 90 degrees right here. So again, do you see that this is not a 30 degrees, 60 degrees, nor 45-degree angle? So not pi over 6, pi over 4, nor pi over 3. Okay, so let's take a look at the hypotenuse first. So our hypotenuse is what? Square root of 2 squared plus 1 squared. So in this case, I'm going to get square root of 5. So the length for the hypotenuse is square root of 5. Okay, so what we're going to do now is we're going to draw this triangle in quadrant number 4. So let me just go with okay, so the length, this is completely drawn off the scale again, I apologize. So here's 1, 2, and then square root of 5. And our angle theta must go from the initial side 2 towards the quadrant 4. That's going to be our terminal side. So our terminal side is here. So notice that our angle theta has to be negative. Okay, so let me just jot this point down. Those of you who like to use x, y, and r. So this point is 1, x is 1, and y is -2. Okay, so let's go. So cosecant of tan inverse of -2. So this is same thing as cosecant of our angle theta. And cosecant was what? 1 over sine of theta. Now, if you want to use x, y, and r, that's fine. Or you can just know that your answer is going to be negative, so you can toss the negative at the end if you want. But anyways, so sine is what? Y over r. So this is r over y. R is the hypotenuse, so which would be what? Square root of 5. And y value is -2. As you expected, our answer is negative. So no need to rationalize here, so I'm going to box that for the answer. Okay, now let's look at something a little different. So let's go with example 7. Cosecant inverse of -1. Something funky is about to happen, so we're going to start out with the same thing. So let theta be cosecant inverse of -1, and our theta is between -pi/2 to pi/2, but of course theta cannot be 0. So okay, so we get cosecant of theta equals to -1. Oh, do you see why I wrote theta cannot be 0? Because think about it, cosecant of theta is same thing as 1 over sine of theta. Now when theta is 0, 1 over sine of 0 is going to become 1 over 0 because sine of 0 is 0. So the cosecant of theta equals 1 over sine of 0, which will be undefined. So therefore theta cannot be 0. But anyways, so let's do the same thing here. Now cosecant is what? Hype over opposite, because it's 1 over sine. Sine is what? Opposite over hype. So I'm going to have hypotenuse over opposite. And -1 is same thing as -1 over 1. Keep that in mind. Now if you like x, y, and r, this will be r over y. Okay, so now let's do the same thing as before. Cosecant of theta is negative in. Alright, so okay, so where's cosecant negative? quadrant 3 and quadrant 4. Alright, but the thing is, our theta has to be between negative pi over 2 to pi over 2. So this is out. So if anything, it's going to lie in quadrant 4. Okay, so let's see what's going to happen here. Okay, so now what I'm going to do is I'm going to draw a triangle using the fact that hypotenuse is 1. Oops, why did I write that in blue? Sorry. Hypotenuse is 1. And the opposite side of the angle has length 1. Now let's call the bottom length x or something like that. So how do you determine x? So first, remember, hypotenuse squared equals x squared plus the y squared. So our x squared is going to be what? 1 minus 1, which is 0. That means, oh no, x is going to be 0. So do you see what's going to happen? This length is going to be 0. So we need to do something else because there's no way that we can have a triangle. Okay, but let me just draw a picture here. So we had what? 1, and this will be negative 1, and this is going to be 0. Oh no. Okay, so let's try something else. Okay, so if that fails, let me draw a picture of the cosecant graph. Okay, so let me just write down, we have cosecant of theta equals to negative 1, and theta must be between negative pi over 2 to pi over 2, keep this in mind, and theta cannot be 0. Okay, so remember how to graph cosecant? Cosecant is 1 over sine, right? So first, what I would do is draw a sine graph. Oh my gosh. So our faint graph, I don't know if you can see this faint graph is y equals the sine of x. Now remember how to graph it. You have to bump it at the maximum and minimum and draw a parabola. So and that means what? We're going to have a vertical asymptote here. So this will be pi, and our graph is going to go like that. So this is 2 pi, vertical asymptote, and oops, oh my gosh, negative 1's like right here, sorry. Okay, so I'm just going to draw right here. So it looks like we're going to have a vertical asymptote at negative pi. I think this is good enough. You see what's going to happen beyond, towards the left or towards the right of the graph. Okay, so let me just call this theta. Let me just erase this. Y equals sine of theta maybe. Might make sense a little bit more. And this is going to be our y-axis. And the graph that we just drew is y equals cosecant of theta. That's the graph of it. Now let's analyze this. Cosecant of theta equals to negative 1 at where? Okay, so that's the question. So first notice that this point is pi over 2. This is negative pi over 2. And this is 3 pi over 2. Alright, so let's take a look. Now, this function assumes -1, y equals to -1, when theta is either -pi/2 or 3 pi/2 and so forth. I hope you can see that. Let me write it out. So therefore cosecant of theta equals to -1 when the way I drew it, theta equals -pi/2 and 3 pi/2 and yada yada yada, and it goes from yada 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 starting from here. Okay, but theta must be where? But since theta must be between -pi/2 to pi/2, so can you see what our answer is going to be? Yes, it's going to be theta equals -pi/2. Okay, so that implies that theta equals -pi/2. So we just chose this one because theta must be between -pi/2 to pi/2. All right, so now what was our theta? Go back to the very top. Our theta equals cosecant inverse of -1. That's what we're looking for. So I'm going to write it as, therefore, cosecant inverse of -1 is -pi/2. That was a little tricky one, but by looking at the graph, we can always determine the value of the trig inverse functions. Okay, I feel like we're on a roll here, so let's just do another example, and I promise this will be the last example that I'll do for this section. So those of you who watched this whole entire video, thank you very much. Alright, so let's go with secant inverse of -2. If you want to try this on your own, again, pause it and try it on your own. Okay, so I'm going to assume that you tried it. So I'm going to start off with let theta be secant inverse of -2, and our theta must be between 0 and a pi, but theta cannot be pi/2. Do you see why? Because, let me see, let me just go with the next step. This means secant of theta equals to -2. Now secant of theta, this is 1 over cosine of theta. But when theta is pi/2, what's going to happen? 1 over cosine of pi/2, cosine of pi/2 is 0. So 1 over 0, which is going to become undefined. Okay, so that is why theta cannot be pi/2. So let me just erase that. Okay, so we're going to do the same exact thing. So let me see. So secant is what? 1 over cosine, which is 1 over adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent of the triangle. Or if you like x, y, and r, this is the same thing as r over x. So -2, same thing as -2 over 1. So I guess since hypotenuse has to be positive, you're going to have to throw the negative on the adjacent side. But anyway, so let me just go through the same procedure. Now, secant of theta is negative n. All right, ready? So we're going to draw this out. Okay, secant is negative in quadrant 2 and quadrant 3. Okay, now where's my theta better be in? 0 to pi. So let me just write this out. 0 to pi. So it must be in here. Okay, so with that said, quadrant 3 is out. So we're just gonna keep quadrant 2. So our angle theta is gonna lie in quadrant number 2. Okay, so let's just draw that out, see what's gonna happen. So the triangle that we're gonna get is hypotenuse is 2, adjacent side is 1, so this is our angle theta. So let's just call this length maybe y or something like that. So we have 4 equals y squared minus 1 squared. So our y is going to be square root of, what is that? 4 minus 1, which is square root of 3. So this length is square root of 3. So it looks like, let me just draw the triangle in a nicer way so you see what kind of triangle that we're talking about. Okay, 1, 2, square root of 3. Do you recognize this? So we're back to what? So this angle theta is 60 degrees now, isn't it? So it's going to be pi over 3. So keep that in mind. So what's going to happen is that you're going to have to revolve pi over 3 units from here to here. All right, so let me just, oh my gosh, pretend that's touching the center. Okay, our length is 1, 2, square root of 3. And this point is what? X is -1 and y is square root of 3. If those of you if you like to use x, y, and r. So what we're looking for is this angle theta. This is what we're looking for. Okay, so how do you find the red theta? Is nothing but what? Pi minus pi over 3. So notice that theta is pi minus pi over 3. Oh, sorry, maybe I forgot to write this. This is pi over 3. All right, so which is what? 2 pi over 3. Okay, now is 2 pi over 3, is it inside of 0 to pi? Yes, it is. And this is in 0 to pi. Okay, so we are good to go. So therefore, secant inverse of -2 is 2 pi over 3. And here you go. Okay, as I promised, I'm going to stop here. And great job today, everyone, and keep up the good work.